Where's the mountains?
Those aren't mountains. They're waves.
We need the recorder.
Brand Doyle, back to the Ranger now.
We're not leaving without her data.
Get back here now. Get your ass back to the Ranger now. Go, go, go.
Am I gonna make it?
Yes, you are. Yes, you are. Come on. Get to the house.
Is it possible to kill the nature? Is death really happened, or it's just a myth? Because in science you can say at fundamental level or quantum level nothing dies, because for a particle you can say it decay, so it change their form, energy, like you can say one form to another. In our school time we have also heard like energy can neither be created nor destroyed. So what is the reality? What is the actual identity of a particle? Is it possible that a particle can lose their identity? You can say the locus of identity. Is it possible that they lose their identity completely? For example, an electron or photon, any fundamental particle, is it possible for them that they decay, or they can live forever? Because you know there are quantum levels and at which we say like things are immortal, you can never die. For example, you have heard multiple videos like, okay, things can never die, we can never achieve death because of the quantum level uncertainty, and in nature nothing dies, only they change form. But what is the actual reality? We will try to figure it out in this video. What is the real truth behind it? Is it possible that for a particle they lose their identity completely, or it's next to impossible? So we will take every fundamental particle step by step and we will cover everything. So guys, please remain in this video. Firstly, let's take photon. So we say for a photon it's electromagnetic force. So for an electromagnetic force, photon can lose their identity. Yes, definitely they can. For example, in photoabsorption or photoelectric effect, what will happen? Electron just popped out. So it means photon lose their identity because photon is eaten by electron. So yeah, definitely into this case we can say photon can lose their identity. Now we will cover another fundamental, because you know there are 4 fundamental forces in nature. So after electromagnetic, you already know the weak forces and strong forces. So weak force we have heard in our childhood, weak nuclear force, and then also strong nuclear force. So for a strong nuclear force, we are made up of glues, because that we call fundamental force, which is gluons. So that gluons, which we represent by G, that is actually something which can remove or erase the identity or not. We will try to figure it out, this thing also. So let's take step by step. So for a gluon, it's next to impossible. For example, there is a up quark, which is the most stable quark in nature, and then they can never lose their identity. Similarly, there are other quarks also which are heavy, like down quark is heavy if we compare with the up quark. So down quark decay into up quark. Similarly, you can say top quark is so heavy but they decay ultimately into bottom, and then bottom quark decay into charm quark, then strange quark. Strange quark is not heavy if we compare with the charm quark. So like top quark to bottom, bottom to charm to strange to down, and down to up quark. So these are the 6 main types of quarks classification. So we can say a quark can never lose their identity because we are made up of what? Up and down quarks, and then up quark is most stable, because so you can say proton is the most stable quark, because a quark cannot live alone. They need a particle, they live in pairs. So that's why we call proton is the most stable, because proton is made up of 2, 1 up quark and 1 down quark. So we can say, okay, at fundamental level, strong forces are something which can never lose their identity. But what if other forces, like weak nuclear forces? So weak forces, we have particles W boson and Z boson at fundamental level. We also call Z, but that is same thing, Z or Z. Now W and Z boson, they are the fundamentals. They can also never lose their identity. You can say never, because at the quantum level, there is a weak field which is present everywhere around you. So that weak field means their particles, their particle W and Z boson, they are also present. Virtually they are present because if you talk about physical, they are so heavy. You need an accelerator to see them. So without an accelerator, you cannot find it. So you at virtual level, you can say virtual Z, virtual W boson, they are present. So similarly, you can say, okay, at that level, like you can say weak nuclear force, they are present everywhere and they can never lose their identity. But what about the other forces? Because God particle, so God particle, their field, Higgs field, like we call Higgs boson, they are got their particles. So what about the Higgs field? Because in the entire universe, this whole universe is actually in the Higgs field. So what about that? Like it is present everywhere inside the whole universe. So definitely they can never lose their identity. But yeah, they are not heavy, they are so heavy, so they are not present in nature like you see up quark and down quarks. They are not like that. They are actually heavy in nature. So they are heavy ones. They can, you need accelerators to find out, otherwise you cannot find him in nature. Like Higgs boson, which we call God particle, you cannot find it in nature, Higgs boson, because it is so heavy. 170, you can say 125 giga electron volt if you compare with the top quark, 173 giga electron volt. So they are so heavy particles, they are the heaviest one. You cannot find them without accelerators. You need high accelerators like European Space Agency, CERN colliders, then you can find them. So without that you cannot predict them in nature. So definitely we can say strong nuclear force, weak nuclear force, they are something which can never lose their identity. But photon can lose their identity, they can just pop out. You can see in photoelectric effect, photo absorption, photo emission, what will happen? Electron just popped out suddenly and they just strike into metal surface, and then a photon just completely disappeared. So photon is not actually achieved death. I mean, they have not achieved death, but it is still in nature. You can say they can lose their identity at a time, because electron can also achieve death in that way. For example, an electron just come contact into a positron and then they can just die completely, they annihilate, because negative and positive, they just come together and then electron just lose their identity. So it is possible also, like electron completely die, and it does, because if they annihilate, if they come contact with a positron, then they definitely achieve death. And in another case, for example, a black hole just come contact, a electron is eaten by a black hole, then into their way also they will completely lose their identity. You can say the locus of identity, whatever you say. Now what about the dark matter? If dark matter is coming with black hole, so is it possible like dark matter interact with black hole or not? Because black hole are the monsters in universe. They are so heavy, you cannot imagine the size of a black hole. Maybe ultra massive, super massive. There are the broad classifications for a black hole. We have discovered like SMBH, supermassive black holes, ultramassive black holes. So they are also at the local level, there are minimum, like you can say some local level, like whatever, I have unable to find the word exactly, which we called micro black holes. Yeah, so micro black holes also exist. In reality they are not something which exists in nature, but yeah, the supermassive black holes definitely exist. So those black holes completely come contact to a dark matter, then what will happen? Is it possible for a dark matter that they completely just eaten by a black hole? So I think through gravity or geometry you can say, but dark matter is something which remain hidden. They will not show their identity. You can completely show their effect. For example, there are trillions of galaxies. So without the balance, you can say without some magical force, there is nothing you can talk about. Those galaxies completely fly apart, and those trillions of galaxies cannot hold together. So you can say there are trillions of galaxies in this whole universe, and even through telescopes you already know at least 2 trillion galaxies are there in entire universe. So how can these galaxies just remain stable? They just completely come together, they will just break completely, because at quantum level also trillions of particles. So how they manage? Because there is a hidden force. So you can say there is a hidden force or hidden energy, but not at the quantum level, but in the entire universe. there is a hidden power which we call dark matter and dark energy. And in this whole universe, more than 95% universe is made up of dark matter and dark energy, and you can say 68% energy, around 70% energy in this universe are actually belong to dark energy. So we don't know, we have no idea about dark matter and dark energy. For example, Euclid Space Telescope we are discussing, and recently Euclid Space Telescope has delivered some new images for the dark matter and dark energy study, and these are really awesome. So other than that, there is no telescope which we are recently discussing about dark matter and dark energy. For example, Chandra, James Webb Space Telescope, Hubble Telescope, these are telescopes, but they are not working on dark matter and dark energy. They are completely working on other things. For example, we already know James Webb Space Telescope, JWST, is so advanced, but still they are not working on dark matter and dark energy. It is just a new version of Hubble Telescope. So for James Webb, for a telescope which can work completely on dark matter and dark energy analysis, they can just completely make a different map, because we have no idea, science have no idea actually what is dark matter made up of. Maybe it's kind of some different matter which we have no idea, like some pure energy, mathematical, some different kind of geometry, because geometry is what? Actually gravity. If you talk about the Einstein general relativity, the space-time curvature, that space-time curvature we are calling gravity, and that gravity is what? Geometry. So that geometry, or you are calling gravity, is present everywhere in the entire universe. So that geometry is definitely coming contact to a dark matter, and into this way you can say dark matter completely coming contact to a black hole, but that black hole will not eat dark matter. That's why you can say in normal matter make stars. So we know already at quantum level also proton, electron, proton, neutrons, and you can say there are different stars, trillions of galaxies, but those are completely made up of ordinary matter like proton, neutrons, but they are not made up of dark matter, because dark matter are completely something which are remain themselves like ghost. They actually pretend like they didn't exist, but in reality they does. So it's a question for a science how we will try to find out dark matter, because till history we have no idea what is this matter actually, what we are made up of. And if you talk about the quantum level, we will say okay, up and down quarks. So if you just open up quark, there is nothing. They are completely empty. For example, there is electron. An electron you can say fundamental particle, but if you just release an electron, if for example at the quantum level, if you just go inside an electron, there is nothing, no space. It means what we are made up of actually, we have no idea. Science have no idea. Like more than 85% universe, more than 95% universe actually are made up of dark matter and dark energy, and we have no idea behind it. We only know around 5% universe. If you talk exactly 4.9%, that is an ordinary matter. Other than that, more than 85% universe are completely hidden from our senses and technology. So I have no idea behind it. So we need a telescope, and which we have recently, Euclid Space Telescope. They are working hard on it, and we will get some different images in future hopefully. Right now we have some different images, but they are not so broad that we will get some information about dark matter and dark energy, but we will need to figure it out in astronomy or science, what is actually dark matter, what is actually dark energy, because it is so important. You cannot exist without dark matter. Maybe you are making not a complete sense, because you think okay, there is a force which is remain hidden and show it like a ghost particle, so how they can play a key role in our existence. But it does. For example, our galaxy is not so big. Their supermassive black holes is not enough. Their mass is not enough if you compare other galaxies' black hole. So that black hole cannot hold their masses, because you know in the at a galaxy level there is a big supermassive black holes, SMBH, exists in the center, and that is the only thing in the entire universe, a black hole which we call, they can actually hold the mass of a galaxy. Otherwise the galaxy will completely fly apart. So we will only reach out to the conclusion in our galaxy which we call Milky Way, that is actually made up of 4 million solar masses heavy black hole which is at the center, and we have no idea behind it, because that center which we are calling a black hole or AGN, active galactic nuclei, because there are different broad classification for galaxies or stars also. Similarly, if you say for a black dwarfs, Black dwarfs really exist or not, science have no idea. For a black hole, what is actually black hole, what is inside the singularity of a black hole, science have limited knowledge about black hole. We are not so advanced like we know what is black hole. Black hole, we only know, okay, star dies, black hole, they evaporate. There are different kind of phenomena which we observe about the black hole, but still we need to figure it out what is actually inside the black hole, what is the singularity actually, how they can achieve the infinite energy, infinite masses, we have infinite density. Science have no idea. We still need to figure it out what is actually dark matter, dark energy, and how they interact in nature, how nature actually deal with the forces, because at the quantum level nature completely does different behavior, they show different behavior. For example, electron is also swirling, the electron is also zipping. At the quantum level things are also happening, but if you're comparing with the broad level, it's a complete game changer. They show complete different game. At the quantum level you can say electron is zipping. For a galaxy, if you comparing it, the galaxy is also making, they are also doing some things, like they have their own speed. For example, Milky Way galaxy, they have their own speed if you are comparing with the Andromeda galaxy. So there are a different broad classification for galaxies also, which we call it like comma clusters. Like you can say for a galaxy they can beard, spiral, lenticular. There is a broad classification. So for a black hole also we need a different or more broad classification, because still we have limited knowledge about black hole, we have a very limited knowledge about dark matter and dark energy. Still we have no idea what is actually dark matter. So guys, what do you think? Science will ever need to figure it out? Will science ever find it? What is actually dark matter? What kind of geometry or some hidden force is present in nature? They actually doing all the things, and we are acting like ghost for them. But for them you can say they are completely hidden. For example, neutrinos didn't act with the forces usually completely. They can say W and Z boson, they sometimes does, but otherwise without W and Z bosons, like without fundamental these weak forces, in nature they didn't interact. So for likewise a neutrino, they are completely ghost. Dark matter is act like ghost, they didn't exist, but in reality they does. So we still need to figure it out what is actually dark matter, how they are actually playing a key role, and it definitely does. Without that dark matter you cannot assume your existence, because the galaxy will completely fly apart, your solar system which we are calling. So that solar system, the planet, these all are things which cannot assume without dark matter. Dark matter is completely playing a very important role in our existence. Thank you.